Hello everyone, and welcome to this Thales Press demo lesson, where we're looking at ways of encouraging a sense of discovery, mathematical wonder, and beauty when it comes to measuring circles. My name is Winston Brady. I'm the director of Thales Press. I have here a lesson plan on measuring circles, and I'm joined here by my friend Joe Wolak, who's going to walk us through all of the mathematical terms and principles and ideas that we need to communicate to students so that they can discover on their own this amazing principle concerning the nature of pi.
Thank you for having me.
Yeah, it's my pleasure.
Yep.
So we've got a lesson plan that's available for free download. This is something you can do for Pi Day, right? So Pi is 3.14. A lot of people will celebrate Pi Day on March 14th. They will ask students to memorize the digits of pi. They will also just eat pi. But I think this could be a good way of calling attention to this amazing mathematical principle. Joe, how do you typically celebrate Pi Day?
So I think that pi in general, whether it's on Pi Day or when elementary students are learning about circumference and all the different parts of circles, that you want them to understand what pi is and the nature of it, not just giving them the answer of like, okay, well, if we use this number, this magical number, it's 3.14, now let's move on. I think that like being able to discover what pi is and how it is derived is very important.
And how would you explain the nature of pi just before we get into this and start measuring stuff?
Yeah, I mean, pi is essentially just the ratio of the circumference to the diameter of a circle. And it just works out every single time that you do it. Obviously, we'll have some human error in our manipulations here, but it's just a ratio is all it is.
All right. Well, the lesson is really easy to do. Really just need string or perhaps a circular tape measure and a ruler to go about measuring the circumference of real-world objects. And we're going to start off with this coffee mug, Teenage Mutant Ninja Turtles. Joe, here you go. Here's the string if you want to go ahead and start measuring it.
All right,
and I'll record the values here.
All right, so I'm going to measure around here and kind of mark my spots on where that ends up. So right here. And then I'm going to measure this here, and I get pretty much exactly 14 inches. Okay. All right, so now you need to know the diameter of it as well. I'm going to flip the coffee mug over here. Obviously, we will talk about, like, you want to make sure the students have the knowledge of the vocabulary and prerequisite skills and everything like that before they do this. Okay, do this. Measure here. We got probably, let's say, right around 4.5.
All right.
4.5 inches.
So in this case, the circumference is the area around the circle. The diameter is going to be an imaginary line going through the center of the circle from one end of the circle to the other.
Exactly.
All right.
So, okay.
If your students can do division with decimals, they can go ahead and just do this by hand. You can also students can use a calculator. When we calculated this, the ratio here is 3.11, which is pretty close to the value that we know as pi, 3.14. But the students aren't going to know that, right? They're trying to discover this amazing ratio that governs the properties of circles.
Yep.
All right, so let's go ahead.
All right.
We'll do another object.
Okay.
And I think with this here, yeah, it's a dinner plate. But with this, the goal is that students would be measuring like a variety of objects. So coffee mugs, glasses, frisbees perhaps. But we're measuring a variety of objects here, and that way they can see that the governing principle, the thing that stays the same, which is what's so amazing about mathematics, is this ratio. So it should always come out to something close to 3.14. Since we're dealing with a lot of human error here, it is going to shift a little bit. Our first value for the relationship of the circumference to the diameter of the coffee mug was 3.11. What do we get here?
So I have a circumference of that plate being 29.
Okay.
29 inches.
In a diameter of?
And let's see our diameter. Diameter of a little more than 9. So hang on, let me measure that again. That seems kind of high. Yeah, about 8.5. Let's call it 8.5.
8.5.
Yeah.
And do you want to do the calculation?
Sure. All right, so we had our circumference, and we're going to divide that by the 8.5, and we end up with about 3.4.
Right.
So a little higher than what we know to be pi, but again, there's a lot of human error that goes into measuring all of this.
And we can do one more. So the plate that we have here does have like a little lip around the side, and just to give us another like object to measure.
Object, yeah.
But the goal is just that the students would see that the thing that stays the same is this ratio between the circumference and the diameter.
So about, let's see right here. about 19. Close to 19.
All right.
All right, now our diameter.
Certainly we can give students a formula to memorize and a definition concerning, this relationship here, circumference to diameter. But having them work it out longhand by measuring objects in the real world is a wonderful way for these ideas to really sink in.
Oh, we got a diameter of right around 6.
Okay.
Pretty much exactly 6. 6 inches there. So if I do 19 divided by 6, I get 3.16.
All right.
So that's our closest one so far. So, and you could give them multiple, even more of these to record, and they will see that you're going to get about the same number every single time.
And how would you do this with a large class of students?
I would definitely put them in pairs, or maybe even small groups, just to help manipulate all of this, and then record it. And then I would have them, if you can, have different objects for each group, if possible.
Different
right?
sizes.
Yeah, different sizes for each group, just so they're not all manipulating the same object, so they all have different circumferences, they all have different diameters, but you still get the same ratio every single time.
Yeah, and that's what's important, right? That's the governing principle that stays the same regardless of the object that we're talking about.
Exactly.
So different coffee mugs, different plates, different Frisbees,
Yeah.
different glasses, what have you.
Exactly. And you can even manipulate small circles to cut out or something along. It doesn't have to be anything fancy. I would have the students then present their findings, maybe 1 per group or 2 per group, depending how large the class is. And then all the other groups will see that no matter the size of the object, the ratio is the same no matter what. So, and then you can move forward into circumference of a circle being, talk about formulas and things like that, and how one formula relates to the other.
Last question. What grade level would you recommend this for, Joe?
I guess it depends on what you are looking for. If you're looking for a Pi Day activity, it's great for lower middle school, where they already know circumference. They know that pi is 3.14. They know what a diameter is and things like that. If I were to do this lesson for a real, not special lesson, I would say upper elementary school. They need to know perimeter, but they should know perimeter of rectangles and triangles and things like that, and then they can easily relate circumference to perimeter. But before they've been introduced to what diameter and pi and all that kind of stuff actually is, they can have the discovery part to it.
And how long do you think this lesson should take? Class period, 45 minutes?
45 minutes would be good, yeah.
Okay.
I think, yeah. And then make sure that there is, because anytime you do projects like this or any type of manipulatives, students will work at different paces. So make sure that maybe you have something for them that relates to the lesson to just naturally go get or naturally work on when they have finished their graphic organizer, if they've done that before you are ready to present findings, I guess.
Yeah.
So.
Well, Joe, thank you so much for walking us through how to measure circles in the real world.
You're welcome. Thank you.
And if you're interested in this lesson plan, just check out the comments below. We'll have a link to a free download, and we hope that this is a blessing to you and your students and makes it easier for you to teach and for your students to study everything that's good, true, and beautiful. For Thales Press, I'm Winston Brady. Until next time, stay classy and stay classical.